So I'm going to talk to you guys today about the anatomy of a huge Python project. Now, before we dive in, let me ask a couple questions of everybody. Who here has heard of Salt and SaltStack before? Wow, really? It's like the worst I've seen in years. Well, it's on your lanyard, so you all know now. It's the first time we've done lanyards. Okay, so let me start by talking about, what is a huge Python project, or what is a huge open source project? And so I've got some numbers here that do some comparisons between different projects. I'm going to talk through some of these numbers, some of these metrics that we use to determine how big projects are. And I'm going to do three main comparisons, which are obviously listed here. Okay, so we've got the SALT project here in red, the OpenStack Nova project, and then Python itself. So OpenStack Nova is the green line, and Python itself is the blue line. These charts and graphs are great. I love them because my line's on the top. But there's a lot more that needs to be told out of the story when it comes to evaluating what it means for a project to, well, be big, and how that impact is really representative in the project. Because every project is different, every project has different types of contributors, and it's really important to understand the underlying dynamic of the project instead of just looking at it and saying, ooh, they have lots of big numbers. So we go to Olo, and wow, that's bad. I mean, not very visible. We go to olo.net because they do a great job of tracking these numbers, and we can do side-by-side comparisons with different projects and get a feel for more of what's going on inside of this project. We can see what the indicators are to say, do they have a large number of contributors who don't give them very much? Do they have a small number of contributors who are really driving the entire project? And so we come through, and I imagine you can't see this, and this is a rasterized image. But so we've got the all-time statistics here. So Salt has had a little over 1,000 people have worked on the code base. OpenStack Nova, that says 792. And then Python itself, 204. And then we've got the total number of commits and how old the projects are. So Salt's got 35,000 commits, OpenStack Nova, 28,000. Python itself has 92,000. Of course, Python's a lot older than projects written in Python. Funny how that works. But so a lot of people like to look at, oh, what's the dev count? But it's really important to come down here and, again, make these more finite comparisons. So we look at Salt, and this past 12-month contributor numbers, funny, GitHub tells me it's like 800, and Olo says it's 600. I'm not sure which one to believe. So I usually believe GitHub because it's a bigger number. Okay. And so we can see how many total lines of code have been added to the project and by how many people. And so we've got 1.556 million lines of code added in the last 12 months. So that's a fair chunk of code. And so, you know, it would be a red flag. I don't know if red flag is the right term, but it would be something to question what's going on in a community if you had a ton of developers and there'd only been like 15,000 lines of code added in the last year. Okay? But something that I think is really interesting, we come over here to OpenStack Nova, those numbers line up pretty nicely. You've got a large number of developers, and each developer is contributing a reasonably large amount of code. But we come over here and we look at the Python project, and this is one of the main reasons why I want to put the Python project up here. We've only got 65 people committing code in the last 12 months, but it's an abnormally large amount of code. And so we begin to see that the people that contribute to the Python project itself contribute large volumes of code. They are extremely dedicated, and you've got a very professional, very intelligent core group that is managing and pushing it forward. This sort of phenomena is something that we see much more commonly in older open source projects than in younger ones. In younger ones, it's more common to have a large number of contributors and a little less code. And one of the big things that I think is a stepping stone for a project is when they start to see the equilibrium that we're seeing over in these columns, where you've got a large amount of code supported by a large amount of people. Okay. So those are just comparing a couple of big Python projects. Django's numbers, just for the reference, are pretty similar to OpenStack Nova's. So then if we could, I like this one the best, to compare against competition. And again, it's fun to make graphs where your line is on top, but it's all about picking the numbers. And so we need to always remember what Mark Twain said, is that there's three kinds of lies. There's lies, damn lies, and statistics. So yes, my number's on top against Puppet and Chef. We compete with them, we're better. I'm biased. We're still better though. But so we come back in here and we dissect the numbers and we start to see what I think is more important metrics to follow is what is the total stability of the project? What does the growth of the project look like? And so we've already seen the SALT column, but again, compared to the number of developers that we're seeing in the last 12 months on Puppet and Chef, they have pretty stable numbers. So Puppet developers are putting in a high volume of code relative to the number of people who are in there. We win again. Okay. But yeah, so we look at the total developer count and we're able to see just the size and scope of the project that we're working with. Okay? Now the last one I wanted to put up here was to bring in a bit more of a contrast of different projects. So we've got SALT there again, but now we're next to the Linux kernel, which is ridiculous in size and scope. The Linux kernel has had 44 million lines of code sent into the project in the past 12 months. That's a lot of code. And it's a very old project. And it's had 12,800 plus people contribute code to it over its lifetime. And so again, the total number of developers lines up nicely with the amount of code that's being contributed. It has similar characteristics mathematically to the Python project in that even though that's a high number of developers over the past 12 months, it is proportionally large compared to the actual amount of code that is going into the project. So again, we've got very mature development and very mature developers who have been working on the project for a long time and who put a very large amount of effort into it, which very strongly also attributes to the stability of the project. So again, as we see these numbers flip as a project begins to get older. And then I wanted to put Docker up here because what we see inside of Docker is also very similar stable numbers, which is extremely impressive for a project so young. Because again, they've got 1 million lines of code, 516 developers in the past 12 months. So they're lining up nicely. Okay? So the intent there was primarily to just give an overview of what do we mean by a huge Python project, and to validate that yes, SALT is a huge Python project and I'm not just being an idiot standing up here pretending like I know what I'm talking about. Okay, we've got a couple other slides here with respect to showing large projects. The GitHub Octoverse in 2012 listed us as the 8th largest developer community in all of open source in 2012. So that was when the SALT project was less than 2 years old. And we are easily the youngest project on the list. And then for 2013, we had the third most merged pull requests and the third most closed issues. So as you can see, it's not just a question of we've got tons and tons of code that's going through the process, but there's a lot of people management that's going on. Because when we're talking about, at this point, merging more pull requests than almost everybody in the world, and then the follow-up fact that on the issues closed here, we're going up against Homebrew, which, they make an issue by updating a package. It's part of their workflow. All right. So what I want to talk about now is shifting gears a little bit more on the SALT project itself and less on the total comparative scope. And start to look at this and go through kind of where SALT came from. One of the things that I was excited about with giving this talk is that a lot of people who sit down and talk to me ask the same questions over and over again. They say, where did SALT come from? Where did you get the idea? How much work did it really take to get it to where it is? These sorts of things. And so I've laid out some of the philosophies behind it, some of the numbers that we look at, and some of the management techniques that have been used to take the project from my basement, where I started at night, into being now one of the world's largest open source developer communities. All right. So a lot of different projects start in different ways. We can look at Mongo, for instance, and Mongo was started by the company 10gen because the original 10gen company actually had, if I'm not mistaken, or so I have been told by people at 10gen, that the original company had slightly different intentions instead of making a database. And so you've got some projects that are a little more company-sponsored when they get going, and Cassandra, for instance, came out of Facebook. So you've then got projects that are more lone wolf. I don't know if Mosaic should be up there. So Salt Stack is a basement project. The Linux kernel, of course, we all know where that came from. And the famous first post and Linus getting yelled at by Tannenbaum. Okay, and then things like ZeroMQ, which was started primarily by 2 people. All right. But so even though we go back and we look at the different types of ways that a project starts, it becomes a very heavy influencer in how that project goes, how it evolves, how it is managed, and what direction it goes into. Because different projects, again, go in different directions. Salt Stack, we've formed a company, we have customers, people pay us money now, it's great. Boy, that's great when that happens. But then we look at the Linux kernel, for instance, which is still very much so a foundation. Okay. So I had a professor back in college who liked to tell us that the days of the lone wolf developer or the developer who was able to make something on his own and make something that mattered were dead. He would tell us this all the time, that you have to think and work in the structure of a team. And I really like coming out and saying that I don't think that the lone wolf developer concept is dead. I shouldn't say the lone wolf developer, that a project can't be started by an individual. A project can clearly be started by an individual. But everything else that professor of mine was telling me about was also very important. One of the most important aspects, and one of the things that I feel has led to SALT's community development success, has a lot to do with its modularity. So the code base itself has been built around the ideas of being able to work in a large team structure. This is one of the most important things that helps us manage the code base, is that somewhere in the realm of 85 to 90% of the code base exists in module layers, so that every aspect of the system is pluggable. And so the benefit there is that when you've got a lot of plugins that are out there, it's very, very easy for individuals to function in an isolated scope. So if you've got individuals writing code in an isolated scope and contributing it, and then you've got guidelines that ensure that certain code quality is up to spec, it's a lot easier to incorporate a lot of brains, a lot of minds into the same project. And so let me actually hop out here with this incredibly low resolution and look at the project. So we go into the code itself, into Salt, and most of these directories are only filled with plugins. And so, for instance, if somebody goes into the execution module directory and decides that they want to make some additions to how we manage, just trying to pick something at random here, DDNS, the modifications that they make to this file are mostly isolated to this file. They're very safe in making those modifications, okay? So again, when we start talking about anatomy, the actual design of the code base itself is very important with respect to it being open to contribution the way it's architected, okay? Now the other follow-up is community. So I started the project in my basement. Sorry, I've said that like 4 times. I'll try and stop. But shortly thereafter, we start to get this community building up around it. People coming in and saying, oh, we're using Salt and we've got a question for you. And then my response was of sheer horror, because, you know, I've got a project that was 6 months old and I find out that Salt is now powering a large portion of LinkedIn's development environments. And needless to say, I was a little nervous about that. But that community outreach is one thing that's extremely important. So one of the policies that we have is that when somebody files an issue or gives us code, it does not sit unattended. It must be triaged immediately. That individual needs to know that what they're asking us about or the bug that they've filed is important and that we are working on it, and that if they want guidance so that they can help us fix it, then they're going to get that guidance. We look at how different communities are run, and we begin to see why certain attitudes or philosophies tend to group around a community. And so again, my goals building the community had to do with if we are a nurturing community, if we are a community where somebody can come in and say, look, I don't even know Python that well, per se, but I want to contribute to your project because I think that X, Y, Z would look good. Some of my favorite stories, we had one individual, I'm not going to say his name because he'd be embarrassed. He's a real good guy, so I won't embarrass him. But he gave us a pull request which was absolute garbage. Every time we bring a pull request in, we run a pilot check on the pull request to see if, you know, there, you know, tabs and spaces and things, or, and we do disable many of the ridiculous things pilot looks for. And this guy gave us a pull request, and it had something like, and with our settings set in, it had something like 600 pilot violations, and the pull request was maybe 100 lines. And so our response was not to just go, come on, really? And close the pull request. Our response was that we sat down, we fixed a majority of his lint issues, the ones that, you know, could be reasonably fixed, like white space and things. Gave it back to him and said, here's the fixes for the lint issues we could take care of. Can you please finish it up? He finished up the other lint issues, and we got that code merged. Did that take more of our time? Yes. Was it worth it? Yes. Primarily because that individual now gives us perfect code every time, the first time. It took him 2 or 3 more pull recs to get to that point, but it happened very quickly. And now he gives us maybe 500 lines of code a week on average. And so the end result was that since we sat down and we said, we're going to be good to people, we're going to be nice to people, we're going to help them learn how to come into the project, then they become more loyal to the project. You build a culture in the project so that when somebody else comes in and gives us a disaster pull request, that person we helped before now helps them. And you build a positive community where everybody is watching everybody else's back. Because the end goal is, how can we build a big and successful project, and how can we make this software do what it needs to do at the end of the day? Okay? Now this is one thing that I wanted to talk about a little bit that kind of leads into this, is that different projects end up getting different personas. And different project leaders manage things very differently. So, I mean, you can think about how Guido van Rossum manages Linux, or Python, with respect to how Linus Torvalds manages Linux. Because, I mean, Guido gives a lot of other people sufficient power to do a lot of things. Whereas Linus Torvalds says, I am the final say, but I trust my network. And then we look at others that become more community-oriented. So, I mean, we can't necessarily name the Lord of the OpenStack project. And same with Apache. It's a lot of people working on this thing together. So regardless of how the project is managed in these respects, they can still flourish. They can still become big projects. Is really the only thing that I'm trying to say. I don't think that any particular approach is better than any other. Now, one thing that I do want to follow up on is that I have noticed that people who have been managing projects, BDFLs who have been managing projects for a longer period of time, tend to be a little more aggressive and can be, you know, seen as a little more rough around the edges or a little meaner. And that's something to keep in mind if, from managing an open source project, is that you really hate trolls. There's plenty of people out there who like to come up to you and say, I know that you're giving the world something for free, but I'm mad at you about that. And that's a terribly unreasonable thing. Well, I think so. But I'm on the receiving end. I'm sure they think it's reasonable. But so a lot of how a community can be defined has to do with how you respond to these sorts of things. Now, the way that we respond to criticisms is that we respond politely and positively. And we have found that one of the best ways to diffuse somebody is to agree with them. And so somebody comes and they say, your default templating engine for your config management system is Jinja, and I think you're a twit for doing that. How dare you? This is idiotic. And we say, we perfectly understand your concern, and we agree that there are reasons why people might think this isn't the best approach. Here are the reasons why we've done it this way, because that templating language is very popular. It makes sense to people who are familiar with things like Django. And this is how you can use an alternative. If you have any suggestions as to how we can improve the situation, please let us know. And typically they come back and they say, oh, okay. Because we've discovered that most of the time, not all the time, every now and then somebody's just, you know, nuts. But most of the time what happens is that a lot of these guys are so prepared for a fight. They just expect a fight, and when they don't get it, they don't necessarily know how to respond. I had a great experience just the other day. Somebody sent us something and was railing on some code, and I responded very positively and said, you're right, thank you, you found a serious issue, we will get that, and we got it fixed immediately in the code base, and he then sent me like 5 private emails saying, I'm terribly sorry, I'm so sorry, I'm so sorry. So we have discovered that somewhere in the order of 90% of people who are posting criticisms can be diffused because they don't mean to be jerks. Okay. Now, the next thing that a lot of people ask me is, how did you come up with the idea for the project? And how did you build the project up to where it is now? So I'm actually embarrassed by this slide. My marketing guy was very insistent that we put a slide in about me, and I changed the title. Okay. But so SALT is an automation framework for infrastructure management. And in a lot of the pieces I say for systems management, because we've got guys using SALT for not just infrastructure management, we've got guys using SALT for supercomputer creation and management, we've got guys using SALT for managing medical devices that run on specific types of backbones. Okay. But some of the things to keep in mind with respect to building a project like this is that you've got to put ridiculous amounts of time into it. So for the past 2.5 years, if you go to OLO, I slipped to number 2, I'm embarrassed. But I was one of the most active Python developers in the world for the past 3 years. Consistently between slots 1 and 3, normally on slot 1. But if you want to build a project that gets that far, that makes it big, you do have to work day and night. So in the earlier portion of the project, I did have to wake up in the morning, start work at 8, code until 5, spend 2 hours with the kids and put them to bed and maybe eat something, maybe, and then code until 2 in the morning. And just do this every night, over and over and over and over and over and over and over again. So it isn't something that, you just happen to walk into a room and say, well, I had a good idea, and so now everybody loves me. It is quite the slog to make it happen. All right, now we are, let's see, I've got, 10 minutes? Okay. I don't have to use it all. Okay, I'm actually going to switch gears and skip a couple of these slides and come back to them. A lot of people ask, okay, if you're getting that many pull requests, how do you process them? And so I wanted to actually walk through processing and merge a pull request or two. Okay. I think we've got 17, 18. Once happened since the talk started. So we come through here and we look at these pull requests, and like I was saying, we go through a lot of effort to nurture and build up people and build good code that comes in. And so we can see the number of comments that are associated with each pull request. So all of these that are still hanging around, this one that's terribly old, it's old for a reason. We aren't just, neglectful jerks. And we can look at an old pull request. Oh, that was me. Sorry. We can look at an old pull request and see, of course it's old. It says not ready for merge. Make sure it goes into the next release. And then we have lots of comments, lots of ongoing work. Yeah. I think he's almost there. Okay. Now the other thing is that every time a pull request comes in, we run a test suite against it. Now we come back and, and then the test suite comes back and reports back to GitHub, as you can see, what's going on. This helps immensely. Well, the code quality shot through the roof when we got this going. But so we take a look at it, and so we see that Jenkins is doing that lint test I talked about. If you look at our PyLint RC, you can see the many things that, yes, are disabled. And then every time we update Pylint on the Jenkins server, we've got to either like fix crazy new things or disable new things, because they like to add stuff. But I have to be nice to those guys who write Pylint, because they are awesome and heavy salt users. And give us code. Okay. So then we can dive in and look at the test suite and see exactly that this guy is just butchering a bunch of tests. And so there's a lot of legitimate reasons why this has not been merged yet. And then our test suite is very thorough in how it functions. One of the problems that we run into with testing salt is that we don't have that luxury of being able to say that there's just a bunch of functions, we've got to make sure they go. But instead it's, oh, this is a distributed network and infrastructure management component. And we have to test the distributed and communicative nature of it. And so our automated tests start up an integration suite, which creates on a single machine a very complex salt deployment that mimics a multi-data center tiered system and then runs all the tests through it. So that we've got as live of automated tests as we can for each pull request. And then those tests for each pull request get executed on that one. Where's the tab I want? There it is. For each pull request get executed on CentOS 6, we'll be moving that up to 7 soon by default. And same, this one's going to go up to 1404 pretty soon. Because those are the biggest platforms that we get deployed on. But then once code is merged, we test it against many more platforms. Okay? And it's embarrassingly red right now. it was blue last night. But of course, I'm giving a talk, which means something has to break in my my head Git branch. Okay. So let's look at a pull request that we can actually merge. Where's that one that I saved? That one. So every now and then we get some of these fantastic pull requests from people that we know, people who are heavy contributors. So Ryan Lane is the person who architected much of the Wikimedia backend, which is a heavy salt user. He's over at Lyft now. Just put out a great blog post comparing salt with some of the other tools that are out there. And he didn't hold any punches, but we still won. Okay. But yeah, so we're able to go through. This is a tiny update to code that I know that he authored to begin with, so he's the maintainer of the module anyway. And it makes it really easy to say, oh, the test passed. Let me just double check. Yeah, there aren't any flukes in Jenkins. They did legitimately pass. And so we can merge a pull request. Okay. And then my constant fight to keep this number below 30 continues. Okay. Now, I'm probably gonna skip the whole where did the idea for salt come from talk and why did I use Python. Does anybody want to know why I used Python?
Yes.
Okay. Python's awesome. All right, next slide. Okay, there were a lot of factors in using Python. One of the first had to do, of course, with personal experience. When I started the project, Python was my best language. Now it definitely is my best language. But more importantly, looking at going back to that community architecture and looking back to the architecture that I wanted to expose. Some of the things that were most important to me in developing Salt had to do with the pluggability of and modularity of the system. I didn't want something that's compiling down to a static binary that we can't be constantly and very seamlessly adding plugins to. I didn't want to have to, I wanted to make the plugin system as incredibly simple as possible, which is why Salt plugins are just Python modules. You don't even need to import anything from Salt. You just put them in a directory and they work. And those functions get exposed to Salt. You name them the right things for certain modules and then turn them on in the config and they override functionality instantly. So Python's flexibility and ability to be modular was a really big reason why I went with Python. Another reason why I didn't go with Ruby was because, you know, there are already a couple of major pieces out there written in Ruby. But also because we're very, very concerned about the performance of the system. Salt is the fastest out there for what it does. By a long shot, we consistently win on speed, and usually by orders of magnitude. And we have put a huge amount of effort into that. So, I mean, even the way that we install users on a system is faster than everybody else. We've got, and our techniques for automating the installation of packages allows you to do really cool dynamic batching kind of things. So that, again, it all happens a lot faster. And that does play back into why Python. And another reason why I'm a big fan of Python is because of the maturity and stability of the language. I've talked a lot about stability today and talked a lot about what does it mean for a project to be stable. And we look at a lot of languages that are out there and they tend to do this. They tend to say, well, they're popular today and not popular tomorrow and then popular again, and they waffle. But Python has been on this steady, stable march of just continually getting more and more adoption. And so despite the fact that somebody comes and says, oh, well, you shouldn't use Python, you should do something else, you can always step back and say, but Python isn't going anywhere. And it's not, you know, about to be like bought by Oracle or anything. Does that satisfy people on the reasoning for why Python? Okay. Sorry?
Where'd you come from? What was your strongest language for Python?
I'd rather not say. Java. But mostly because Java in school. And honestly, after school, I haven't touched Java since then. Most of my work has been in Python. I've done a little bit in like some esoterics like OCaml. But yeah, especially now, the vast majority of my experience is now in Python. All right. So now I'm trying to remember where. Okay. Where I am. Okay. So the next thing is that people ask is, where did you get the idea? Because Salt is a very unique project. To make a project that gets big, unique is usually a good thing. If you've just got a project that in its entire scope just copies what somebody else is doing, then there's a limit to how far you can grow. So my main idea behind Salt had to do with this idea of high-speed remote execution. It was the idea that I wanted to be able to get live data from a large number of servers back very, very quickly and crunch it on the fly. I was really, really sick of working with large infrastructures where I was relying on a database that gave me bad information consistently about what was going on in an infrastructure. And Salt is actually the fourth iteration of me trying to tackle this problem, but the first time I got to make it open source. And so the end result was that at that point, I'd understood the reason why it needs to be highly modular. I'd understood the reason why everything in Salt needs to be JSON serializable. All data that's transferred around is JSON serializable inside of Salt. I mean, even the config management system, it's all just dictionaries and lists. one thing that people commonly say is that salt isn't magic. It's just a bunch of Python dictionaries. Okay. And then since then, it's grown into having all of those necessary tools, and I shouldn't say all of, most of those necessary tools to do anything that you need to do to automate an infrastructure, which is also someplace that we usually win in competition, is that people come back and say, well, at the end of the day, salt can do 10 times more than anybody else can do, so we use it, and it's still fast and lightweight. All right, now I'm just about out of time, and so I guess I'll wrap up. I did want to say a couple of things. We are a company. We are rapidly growing right now. And a lot of people have asked about what I do day to day. I don't get to code as much anymore, which is a sad, sad thing. We reviewed pull requests. I told you some stories. And apparently we've got a gift card raffle because we're sponsors. I'm not wearing my lanyard. As you may have noticed on your lanyards, these are the coolest lanyards I've ever seen. All right. But that's that. Thanks for coming.